In this segment, I'd like to talk about how integers are represented in Haskell. And the answer is there are two ways of doing it. There's a type integer and there's a type int. So the integers are the whole numbers. They're 0, positive and negative. And mathematically, integers can be of arbitrarily large size. So an integer can have 1,000,000 digits, for example. And the integer type in Haskell will allow you to do that. So you can have an integer in Haskell can be as big as you want it to be. Well, within reason. There are restrictions because of the number of atoms in the universe and so on. But ignoring that, there is no fixed bound on the size of integers in Haskell. On the other hand, sometimes it's an advantage to represent integers in a small amount of space. And this is what the int type does. So if you're doing computationally intensive things, it's traditional to use fixed size integers. And this is what the int type supports. So you have a choice in Haskell. Integers are of whatever size you wish. Int are of a fixed size, allowing much more efficient numerical calculations. Now, what can we do with integers? Well, we can do the traditional things. We can add, multiply, raise to a power. We can take the negative of a number by putting the minus sign in front of it. We can also subtract one number from another by putting a minus sign between them. And we'll come back to one of the issues about that a bit later on. We can do whole number division. So div is the function that does whole number division. So if you divide if you divide 3 into 14, the answer is 4, remainder 2. So div gives you the 4, the whole number part, and mod gives you the remainder part. So 14 div 3 is 4, 14 mod 3 is 2. Absolute value, so removing the result of removing the sign is given by the function abs. And if you want to change the sign of a number, you can use negate, or you can use the minus sign, as I suggested. And there are the usual ordering operators, greater than equal, and so on, which we talked about earlier. So that's what we can do with integers. Now, in fact, we can do exactly the same thing with ints. Now, these operations will have different results because ints are fixed size, but we can still do those operations. And this is through this process of overloading. And finally, we can convert between different types. So we can, if we have an integer, we can convert it to any other numeric type by using from integer. And if we've got an integral type, a whole number type, we can convert that to an integer. So for example, we can convert the integer 34 into a floating point number. We're going to talk about floats a bit later on. And the answer to that is 34.0. So that's how we do the conversion. One more thing to say, when you type things to GHCI, when you type numbers, they default to being integers. I wanted to show you this for two reasons. One is to show you that when you just type integers to GHCI, they default to being integers. When you type whole numbers, they are interpreted as integers. And you can see here, that's the result of the raising 2 to the power of 1,000, which has about 300 or so digits in its decimal representation, because the logarithm of 10 to the base 2 is 3 point something. So we get that sort of representation of a large number. Now contrast that with lower down, 2 to the power of 1,000 as an int is 0. So here's a graphic illustration of how integers and ints differ. Now, just one thing I wanted to point out, and we're going to come back to this quite shortly is how we read, how we represent ordinary language inside the syntax of a programming language. And I've said here, or the syntax of every language represents a compromise between making things readable and potentially getting ambiguity or misdirection. So -12 is negative of 12. But if I write abs, remember this gives you the absolute value of -12, I get an error. And the reason for that is that abs -12 is read as a subtraction of the number 12 from the function abs. And clearly there's a problem there. You can't subtract numbers from functions. So in order to get what we want, we need to put that -12 in parentheses. And there's a general piece of advice with this kind of problem. If in doubt, if you're not sure how the computer is going to interpret, how the program is going to interpret what you want to write, putting in extra parentheses to show precisely what it is you want to do is not usually a problem. And what I'm going to do is come back to this topic of how the computer reports error messages to us and how we interpret them in a segment in a few segments time. But for the moment, I just wanted to conclude on that important caveat. Please, when you want to write a negative number, put it in parentheses.